I was asked by a coworker to look at their pole saw, and as usual, they didn't give me any information about it, or I think they like giving me surprises because this one was the most surprising one I've gotten all year. Now, to be honest, I really thought about passing on this project because of what I found while trying to fix it, but as usual, I'm pretty stubborn enough to keep pushing through it, and this time, it came back to bite me in the worst possible way. In today's video, we look at this pole saw, and the problem is that the engine is stuck. Now, the worst part is the way it's stuck, and you'll see what I mean by that here in a bit. Now, this engine is several years old, and the fact that it's in this great condition does kind of make me wonder if it's been stored most of its life. Now, I'm going to try and repair this pole saw, but yours might be a little different, so this might not work on yours. If things aren't working out for you, like in the video, please ask about it, and I'll be glad to answer your questions. The first thing I want to do is to take a look around and look for anything that might be broken, and this time we actually find something. Now, at first glance, it would seem the only problem is that it needs new fuel lines and a bulb, but if you pull on the starting handle, you'll soon realize that the engine is stuck and won't budge. Now, the recoil system has a spring assist, and that's why I'm able to pull on it, but the engine is definitely stuck. Now, not only is the engine stuck, but when trying to squeeze the trigger, I soon realized it was stuck as well. If this happens to you, resist the urge to try and free it by squeezing on it with a lot of force because you could break the plastic. It's best to figure out where the problem is first before trying to break it free. The next thing I want to do is remove the spark plug and see if it's hydrolocked with fuel or even water. The problem is that after taking the boot off, I soon realized there was corrosion on top of the spark plug. The only way this could happen is if the boot was extremely wet, which doesn't happen very easily. After taking out the spark plug, things go from bad to worse. The spark plug is covered in what looks to be mineral deposits and just a small amount of rust. It's something you'd see from a faucet that was dripping hard water over a long period of time. Unfortunately to me, from the clues I've gotten so far, everything points to this machine having been in a flood, either completely submerged or partially submerged. And after drying out, the piston is now stuck to the cylinder. Now, I'm not going to fill the engine with transmission fluid or MMO. Instead, I'm just going to use some cheap WD-40. Now, after spraying a few ounces into the engine, I'm going to remove the rear cover for the crank and see what it looks like inside the engine. So if you haven't guessed what I'm looking at, let me tell you what it looks like. It looks like dirt or mud wherever it's wet at. That pretty much confirms that this pole saw was in some muddy water at some point. Now, it's a bit more obvious when looking inside of the engine. You can see a fair amount of mud in there. Now, since it's already had water in there, I'm going to use even more water to flush out the mud. Even after flushing out the dirt and spraying more lubricant into the spark plug hole to get it on top of the piston, and even around the connecting rod and needle bearing, the engine still won't budge. Now, more than likely, the part that's stuck is the piston, and it's stuck to the cylinder. Now, I always get great advice from the viewers, and some have recommended that I put a wooden dowel into the engine and hit the piston to free it. There's just one problem. Now, if you noticed when looking inside the engine, the piston was already in its lowest position, which means it can't go any lower, only up. Now, I've never had to deal with a stuck engine quite this way before, so I'm going to try and take it apart down to the flywheel so I can attempt to rotate the engine that way. For those of you who are paying attention, I hope you realize why that's a terrible idea. After revealing the clutch drum, yet again we see more rust on it. The strange part is it's not covering the entire part, only about 75% of it. Now, after removing the last two screws for the front cover, we can't remove it just yet until we remove the torque screw holding the drum in place. Now, be very careful when taking this part off because if you damage it, you're going to have a rough time afterwards. Now, normally I would have to keep the engine from spinning to take this off, but I might be able to put force on it to free the engine. Now, I really should consider getting the special tool to take this off, but carefully using an open-end wrench works just as well. And as you can see and hear, the engine is now free. Now, freeing the engine was the point of trying to get to the flywheel, but with it free, the first thing I want to do is get a compression reading and see if we need to take the engine apart. So the reading is around 120 psi, which sounds pretty good considering this engine has been in a flood with a stuck piston. Now that we know it has decent compression, which is one part of the three major parts we need for an engine to start and run, the second part I'm going to check for is spark. So as you just saw, there were sparks at the electrode on the plug, which is what we want to see. Now if you don't see any sparks, check and make sure the on-off switch is in the correct position, and if it is, then your ignition module might be bad and needs replacing. The last thing we need to do is to put some fuel into the spark plug opening and see if the engine will start and run for a few seconds. So unfortunately, the engine did not start, which is quite surprising. An engine needs fuel, spark, and compression to run, and we have all three. I have to wonder why won't it start. Now after taking the plug out, I can see that it's wet with what looks to be fuel that we just put into the engine, but I didn't put in that much, otherwise I would flood it. Now after taking off the rear cover for the engine again, I realized just how dirty it still was, even after spraying out the mud. Now at this point, I decided to do the right thing and take the engine apart for a better cleaning and of course an inspection. I do want to point out something, and it's the way the engine sounds when I pull the rope. It's hard to pick up on camera, but it sounds like metal on metal contact, as if the piston was moving inside the engine with no oil and no piston ring. I'll try and isolate it so you can hear it. It sounds absolutely horrible, and I have to wonder if the piston ring is stuck to the piston. Now it all makes sense if you think about it. The piston ring is the tightest in the cylinder when it's at the bottom of its travel, and that's exactly where the piston was stuck at for who knows how long. I have a terrible feeling that even though we got a somewhat decent compression reading, I think the piston ring is still stuck to the piston and needs to be freed, otherwise the cylinder wall is going to be damaged by the piston. After installing a really long and modified spark plug designed for an overhead valve engine, we were able to remove the clutch. The spark plug basically acts as a piston stop to keep the engine from rotating while taking off the clutch. Now once it's gone, we can take the front cover off, which is also the recoil assembly. Now these are the same steps you take the cover off to service it, repair the recoil, and of course replace the rope if needed. Now ours is okay, so we're not going to touch it. Now, to be honest, we really didn't need to get to the flywheel anymore because we were able to free the engine using the clutch, but since we're here, we're going to lubricate the posts and the springs for the starter pawls. The reason is because since we found out that this engine was underwater at some point, we need to make sure these are not rusted and working the way they're supposed to. So we finally come to the two, yes, only two large Allen bolts that hold the cylinder to the engine. Now these have a history of coming loose and causing all sorts of issues, but fortunately these seem to have quite a bit of thread locker on them, so they haven't backed out just yet. Now to help speed things up, I like to drill out this one opening so I can either use a drill or use this large combination tool. This doesn't affect it, so I don't have an issue modifying it. If you think I shouldn't have done this, I'd like to hear your reasoning. After removing the cylinder, we can finally see the piston and the connecting rod. Now to get a better look at it, just slide the connecting rod off the crank. Once off the engine and after taking a closer look, you can see the piston ring is definitely stuck against the piston, which is not the way it's supposed to be. Now if you put a screwdriver against it, you can see that the ring does not extend past the skirt of the piston. It's pretty much flush with the side. There's also a fair amount of carbon on top of the piston, but it's not the worst I've ever seen. Now once I get the ring off the piston, we'll then clean it off using some degreaser. Now I wasn't sure how I was going to free the ring, but after pushing on one end of it, it came loose pretty easily. After that, I then worked the loose end around the edge of the piston, and eventually I was able to get the ring free and off the piston. Once the ring is off, I'll then use my heavy-duty degreaser on it along with a wire brush. Now once clean, I'll then install the ring, and if you weren't aware of it, but the ring only goes on one way. After that, I'll then check on the condition of the cylinder and see if there's any markings from where the piston was stuck at. Surprisingly, the cleaner worked extremely well, which is great news. Now I didn't see anything terrible on the walls of the cylinder, which is great news. I'll then reinstall the piston back into the cylinder and get ready to put everything back on. But before I continue, I'm going to clean more of the dirt and deposits that's on the crankshaft. Now using compressed air might have been a good idea, but since there's not that much to clean, it wasn't necessary. Before I put stuff back on, I'm going to see why the throttle is stuck. Now after checking the throttle plate, you can see it's not stuck, so the issue might be the cable. I'm going to take it off so I can examine it and either replace it or lubricate it. Now I can do that later on, so right now I'm going to install the piston back into the cylinder and then install both back onto the engine as a whole assembly. Now I did lubricate the cylinder with a light coat of 2-stroke oil and also put a medium strength thread locker in the openings for the bolts. Now I cannot tighten down the 2 bolts just yet, and that's because the piston is all the way up in the cylinder and I still have the long spark plug installed. Now once I remove or at least turn out most of the spark plug, will I be able to tighten the bolts down. The other option would have been to turn the engine so the piston was all the way down as well. After the bolts have been hand tightened, check and make sure that the mating surfaces appear to be touching. Now ours looks good, so I'm going to fully tighten the bolts. Please don't ask what torque spec I'm using because I don't have them. Remember, this is a pole saw, not an airplane. Next, I want to put as much of the engine back together so I can do a compression test. Unfortunately, this is when I make a terrible mistake that almost derailed this entire repair. For those of you who are watching, see if you can see the point where I make my mistake, because I hate to say it, it's one of the worst things I've done since working on that steel chainsaw a few years back. So the last reading was almost 120 psi, but what I didn't mention was that the initial readings from the first and second pull are also very important. The overall reading is good, but if it takes you 20 pulls to achieve it, there might be an issue. So this time it only took 9 pulls to get to 150 psi, which is a great reading by the way. It means that the stuck piston ring did have an effect on the compression, even though we got a good reading the last time around. However, I want you to take note of the reading after the first and second pull. So on our first pull, we were able to get 55 psi. Now, if you compare that to the first pull on our last test, you'll see that we only got about 26 psi. That's the difference between having a piston ring that's stuck versus one that's not stuck. Of course, if the same goes for the first pull, it must be the same for the rest of the pulls as well, with the second pull getting about 80 psi versus what we got the last time, which was about 48 psi. Now at this point, after cleaning the inside of the engine and also restoring most of the compression to the engine, I think it's time we try to do a test start, and I hate to say it, but this is not one of my finest moments in my life. So the good news was that it started and ran for a few seconds, but the bad news was the metal-on-metal sound I just heard as the engine was slowing down. If you know small engines and saw what I forgot to do, then you'll know exactly what I think might have happened. I think I damaged the flywheel in the worst possible way. Now after taking off the recoil assembly and then taking off the flywheel, I confirmed my worst fear. As you can see, the key to locate the flywheel to the shaft, which is also machined into the flywheel, is completely gone, which means I sheared it when I started the engine. The reason this happened was because I didn't put the clutch back on, which would have kept the key and flywheel in contact with the shaft, and I simply forgot to replace it. Unfortunately, this is where we have to leave the project, as I now have to figure out just how I'm going to fix this. Will I have to replace the $20 flywheel, or is there a way I can save it without having to spend any money or wait for it to arrive in the mail? So in the end, it is unfortunate this happened, and I have no one to blame but myself, but it's okay though, because I'm going to learn from this mistake, and it's going to allow me to make better decisions in future repairs. So my question is, how do you think I should fix this issue that I made for myself? Should I buy the new part, or is there a crafty way that I can fix this? Thank you for watching. I really do appreciate your time here. Please feel free to ask me any questions about this project or your own projects, and I hope to see you in the next video.